Hello everyone. Welcome to the second talk. I'm going to be standing here talking to you all about the wonderful world of small language models. For you who don't know me, my name is Daryl. I've been a software engineer for over 10 years now, mostly focused on Android, a little bit of iOS, don't boo me. One of the things that I've actually really been passionate about alongside Android development is AI in general. I really do find it a really fascinating subject. I've been following it, particularly for AI agents software, since about 2018, and kind of seeing like the explosion of LLMs, generative AI. It's been quite exciting for me just to watch over the years. So what I want to do tonight is share that enthusiasm with you, particularly for mobile devices. And I'm also going to talk a little bit about a library called MediaPipe, which is a Google library which allows you to interface with LLMs running on your smartphone or small device. So let's get to it. Like I say, we're going to talk about SLMs, so small language models. We're going to talk about what they can do. We'll talk about MediaPipe, how it works. And then to finish off, we'll talk about best practices to keep in mind if you're going to go away and try this for yourself. A lot of it is still very experimental. But that's okay because that also makes it fun. I hope you go away from this talk feeling energized, excited about this wonderful world that's going to be coming to mobile in the next few years. So I guess to start off is, what are SLMs? When I first did this first bullet point, I left it quite blunt and said, well, they're just small LLMs, which doesn't really explain what they are. So I had a little think about this, and I tweaked it to say that they're actually the more focused versions of LLMs. So if you think about OpenAI, Anthropic, they have huge models that are running in the cloud, taking up all sorts of computing power, data centers, that sort of thing. They've got huge amounts of data that they can draw from to answer, or at least try to answer, any kind of question that you want to give it. LLMs can't do that because they're quite constrained by the devices that they run on. So if you think of trying to run a model on a mobile phone, constraints from the internet, offline, you're just not going to get that power that the larger LLMs run. But that's okay because there is plenty of room in this world where you don't need that amount of power. You actually might have a very focused use case, or you may even decide that actually I just want to do this running on my own machine. I don't want to be spending a fortune on AWS costs, Google Cloud costs. I just want to use the hardware that I've got. And this is where SLMs come in great because they fill that niche. They do tend to be ranging between sizes of 1 million to 10 billion parameters, which when you think about the LLMs of OpenAI, Anthropic, you're probably talking about hundreds of billions, if not trillions for some cases. So that kind of gives you a comparison of where SLMs fit compared to the larger models. You're not going to be getting really super accurate answers, but sometimes you don't need that accuracy. Sometimes, especially if you're doing, experimental work, you're working with artwork, maybe you're just trying to work with maybe just a few variables within your use case. SLMs are really good to fill that niche. So there's a couple of types of SLMs. You've got your first type, which is basically just a distilled version of larger models. So what you're tending to see in the industry at the minute is you will have the larger models, running, really super quick. They're the ones in the news. But then you'll actually get smart people, data scientists, hackers, hobbyists. They'll actually come along, download the model, and then they'll actually begin to chop it down, cut it into pieces. And there's a lot of different techniques that you can use to be able to do this. There's something called quantization, where you can actually begin to reduce the size of the model. You can begin to actually just begin to strip away like the different parameters to be able to reduce the size overall. This does come with trade-offs, of course, because obviously the smaller the model that you make, the less information it holds, the less that it knows about. But it's an iterative process as is software engineering. You work on something, you dev it, you see how it works, you try again. This is how these distilled models work as well. You iterate over them, you experiment, and you see, actually, does this work quite well? Does it answer the question in the way I expect? No, it's giving me garbage, I'll try again. And you kind of do that again and again and again until you get to a point where you're actually happy with your model. You run it against the benchmarks. There's a lot of benchmarking tooling in the LLM world where you can actually see how your model compares to the DeepSeeks of the world, OpenAI, Meta's Llama models. You're able to actually compare against those other ones. The second type is task-specific models. So these are really your, you've got one job kind of thing. And if you can't do it good, then, you're out. So this is where SLMs come in really useful, because you may have a use case in your app, in your software, where really you just want this model to just do one little thing. You might ask it a question. You might want to feed it an image. You might want to feed it some audio. And you want it to give you a response. And that's all you want. Again, you don't need a large LLM to be able to do that if you've got a really focused use case. Finally, there's another category called lightweight models. And this is where these models are kind of built from the ground up with being small in mind, but they may be something called multimodal. So they're not just focused on one task. They're a bit more generalized, but you can put them into your apps. You can put them into low-level hardware, and they will run in a very similar way to the larger LLMs. Again, because they're quite small, you're only going to be able to get generalized answers. You may not necessarily be able to get the huge power that you see from OpenAI, Anthropic, but again, SLMs are looking to fill a niche where you've got, low-powered hardware. You may have very specific needs. These are the cases that SLMs can fit. So I went away and I thought, right, if I wanted to download these models today, where would I go? And, how can I find them? And this is what I managed to come up with. So the usual suspects are there. You've got Meta with their Llama models. The 3.2 versions are particularly fine-tuned for running on mobile devices, low-level hardware. Literally just this weekend, they've released the Llama 4, which has a huge variation between the models. So you've got one called Llama Scout, which is the lowest level model. It probably fits just ahead of SLMs because it's kind of in the 20 billion parameter kind of range. But the interesting thing about that is it's essentially the same distilled model as the Llama Behemoth, which is kind of in the millions, billions kind of parameters. But the researchers of Meta have kind of done the same thing as other places where they've distilled models down to create other models. Microsoft are also in the game, so they've got models called Phi. They're currently up to version 4. You're able to kind of interact with it kind of OpenAI, that sort of thing. Google have the Gemma family of models. They did a big announcement starting last year about this, and they're currently up to version 3. Again, this derives from Gemini. So if you're familiar with the Gemini family of models, Gemma is kind of like the little open side project kind of thing. And there's also a huge family of models there as well. You've got kind of multimodal models. You've got very task-specific models. There's one called Code Gemma, which is meant to be very specific to help with code completion, suggestions, that sort of thing. NVIDIA, they've got a model called Nemotron 4. So this is like kind of in the 4 billion parameters kind of range. And this one's quite fun. It's a very, very like to its roots. It's a role-playing model for games. So what I mean by that is you ask it questions about like what kind of game you want to build, and it kind of helps you with world building, storytelling, that kind of thing. Apple with their open ALM. This is kind of a very experimental research piece from Apple. You can go on the internet and download it. It's very focused on like text generation, that sort of thing. Very focused on running on Apple devices, helping with like, text messaging, suggestions, that sort of thing. Moving on to some of the, not the big tech companies, you've got Mistral AI, so based in France. They've got a bunch of models, but they've also got very specific small models. I'm not going to pronounce the French because my French is terrible. I'll leave that to someone else. But these are falling within the 3 billion and the 8 billion parameters. So again, very lightweight, very easy to use, quite small in memory size as well. Hugging Face. Hugging Face is quite an interesting company. So if you're not familiar with the AI world, Hugging Face is kind of like GitHub for data scientists. There's also a similar company called Kaggle, which fits this kind of profile. But as well as being like a repository or like a registry for AI models, they also have their own dedicated team that are trying to come up with models for different use cases. And they've got a collection called the Schmal LMs. And again, these are fitting in like very small like language model kinds of use cases. DeepSeek, so obviously in the news quite recently for some of their breakthroughs compared to OpenAI. They're also in the SLM market as well. They've released a model called R1 Distilled, which is actually quite interesting because it's actually just a distilled version of the model from Alibaba Cloud. So again, Alibaba Cloud have released something called Gwen. But because it's open source and it's available to download, the researchers of DeepSeek have kind of went, right, we'll take that model, we'll have a play with it, we'll add bits in, take bits out, right, it's our model, here you go. But yeah, this is how researchers, particularly involved in AI, are working. It's kind of like us sharing code on GitHub. They're sharing their models, they're sharing their benchmarks and performance levels, and they're encouraging people to use models to iterate on them, create their own, improve on them. It's a quite interesting world, especially coming from a world where this is so natural to us as software engineers. Right, yeah, so advantages. So as I've mentioned a couple of times, they've got very low hardware requirements. I can't be too general about the requirements because of the nature of the models, like some might require more computing power than others, some might require less, but like in general, SLMs do require significantly less than like LLMs that are running in AWS, Google Cloud, Azure. You can literally just run it on your mobile phones or even like a Raspberry Pi if you wish. They can outperform LLMs in specific tasks. So again, like leaning on the task specificness of LLMs. If you really just want to nail one use case, if you have a LLM that you've trained specifically for that job, it's going to know it inside out. Whereas if you try to provide that task to maybe OpenAI, Anthropic, because they've got all this huge computing power, but like it's very generalized, you may get a more general answer that's actually not what you expect. And also because they're very small, they're also quite quick to train. So if you think about, again, OpenAI, they're trying to train huge, ginormous models and trying to iterate over and over again. It's taken a lot of time, a lot of effort, a lot of people to be able to do that. Whereas if you're working with smaller models that require a lot less memory, a lot less usage, you're also going to be able to do that and iterate quite quickly. They can also function without internet connectivity. So as long as you've got the model file, you can upload it to your mobile device, your other device. You can begin to ask it questions, as long as you've got the interface with it, and it'll just work. Okay, it may not give you the perfect answers that you expect at first, but hey, you can prove the point that, hey, I can actually run some sort of AI model in isolation away from the internet, and that's great. You can choose not to do that if you want. You may want to have some internet connectivity for your specific use case, but if you wanted something that's really bare bones and just works, offline, SLMs are the tool for you. And because they're working in isolation, they're also naturally private by nature. So if you're asking it questions and it's giving you answers, that information's only going into the model, and that's it. Whereas, if you're, again, sending information across the internet to LLMs, you don't know what's going on with that information. You don't know, is it being used for training purposes? Is it being used for improvements? You just don't know. There's also good cost reasons as well. So first of all, because you're using a lot less energy, they're more environmentally friendly. You're trying to run it on devices that you charge at home, plugged into a wall. You're not going to need huge data centers requiring vast amounts of energy just to be able to get answers. And just because of that as well, they're very cost effective. So, being able to train them over and over again, you're not going to be like OpenAI where you're trying to literally spend billions and billions and billions on these things just for marginal improvements. You'll actually be able to get a lot more significant improvements for your own particular use case in a lot cheaper fashion. As with everything in life, there's some limitations. So if you're beginning to use an LLM or you've trained your own, it really does depend on the training data that model's been trained on. So you do need to be careful about the bias that's included in that data. If your data set's particularly positive in a certain area, but maybe not necessarily including the negatives, when you start to use it in production or as you're testing, it's going to become increasingly obvious that it's almost like a bit of a nagging salesman, I guess, where it's like, no, this is great, you should do that. Whereas obviously, there's always pros and cons to things. You want something that's a bit more neutral. And the next one about, being less accurate. So if you're going to end up with a use case where actually you're talking about a lot of specific areas, if you've just got one small language model that's running and you're trying to send it 10 questions, 20 questions on every topic under the sun, it'll do its best, it will try, but the actual answers and responses that you get, they may not necessarily be, A, right, B, accurate. You might as well maybe think about speaking to like an LLM or another kind of SLM that may be able to fill that niche. Finally, transparency and explainability. So a lot of these AI tools, models, they're essentially black boxes. So, you have all these people who can build these things, throw a load of data at it, you end up with this file. Very few people actually know how they work, which is quite amazing. Like if you speak to AI researchers and say, hey, this LLM or this SLM, how does it work inside? They go, I don't know. they have vague ideas. It's like neural networks, relationships between things, that kind of thing. But it's quite surprising that, considering this is like the forefront of technology at the minute, we actually don't know the things that we're using. So that could be an issue for the business if what you need is that kind of transparency to be able to say, okay, this is how this exactly works. Because it could be one day where maybe there's like a legal issue, or maybe the company's getting sued, and one of the things that would really be able to bail it out is being able to explain how this thing works. And if you can't do that, you're in trouble. So let's talk about some use cases. So you're probably familiar with some of these. You've probably even used them on your phones. You maybe even used them, playing about on the internet. But yeah, obviously the big one is generative AI. So, obviously generating content, whether that's images, text, video. SLMs can still do this to a good amount. It's obviously not going to be as, powerful as an LLM, but, sometimes that's enough. Like if you've got text prediction on your phone, maybe you just want to be able to predict the next 2-3 words. Yeah, that's great. Let's use an SLM. Content summarization. So again, another probably familiar use case there. So if you've got like a huge ream of text, some of the SLMs, I know Gemma 3, that can summarize a book these days, which is, for something that can run on your device is quite powerful. Vehicle navigation, like this one surprised me. So, but it also makes sense. So obviously you've got, vehicles, with a navigation input, who, are doing routing, or you may even get like autonomous vehicles. You're not going to want the round trip of sending that information to something that's hosted in the cloud and back to tell the vehicle what to do, because that's dangerous, frankly. So being able to put these models inside vehicles so they can actually, respond to cameras. So, they may see a pedestrian enter the road. They need to be able to tell the vehicle to slow down, or alert the driver they need to slow down, or there's an obstacle. That's a really, really neat use case. Predictive maintenance. This is another interesting one. So let's say you've got a building, or maybe even like a piece of hardware, but that 10 years, 5 years, something's going to fail, and you need to be alerted about it. This is where SLMs can come in really useful, because if you've got some sort of agent or some sort of AI that can monitor the crucial components, that can let you know just before the failure point that actually this needs replacing. It's relatively quite cheap to do. So, instead of like things falling apart and it's a surprise, you can get that heads up and make the necessary repairs. It's really interesting. Educational aids. So I think one of the great things about AI is that they're huge reservoirs of knowledge. And if you're using an SLM, you may want to train it on a very specific subject. English, maths, science. Being able to ask questions as a kid to something that would be able to give you that information. Like I would have been really excited as a kid if I had access to that. I was reading books. I was using dial-up internet. So, being able to have something that I could actually just go, oh, but what about this? What about that? And it responds to me like that. Like I would have loved that as a child. Language translation, I think we're all familiar with this one. Obviously, you can be able to do it offline. You might be able to have like specific languages, that sort of thing. Healthcare applications, so again, quite similar to predictive maintenance, but probably used in a bit more of a serious context, I'll put it. So, trying to, help people to improve their health, maybe just monitor their health, give them alert if, certain things don't seem right. These are things that, SLMs running on devices that you own, can help with. Cool. I need some water after that. Okay, cool. So now that we know what SLMs are, I'm going to shift gears and we're going to talk about MediaPipe. So yeah, MediaPipe is a library from Google. It was originally created to help with like audio and like video applications. So, being able to detect like movement of a body, using the camera, being able to do face detection or like person detection. So if you've got like 4 or 5 people, you'll be able to actually identify those 4 or 5 people. Not in like a creepy way, just kind of like, hey, this is cool tech. Yeah, so this was a while ago, but like more recently, they've kind of moved it more towards like the LLM, SLM kind of like area, which I think is a really smart move. It provides a lot of plug and play functionality, and what I mean by that is there's already a lot of like pre-trained models that you can use with MediaPipe. You import MediaPipe as a dependency into your Android app. You've also got to import the models, because these models are quite chunky. Some of them are like 100 meg, and now if you're going into like SLM territory, it's a couple of gig. Some are half a gig, but it's it's not something that you can just import in as like a dependency. There's also a lot of customization options available. So kind of the things I was talking about earlier, where you can distill models or you want to change models. MediaPipe allows a lot of this customization to happen. So if you've got a model and you want to tweak it for yourself, in some way, MediaPipe gives you the tools to do that. So you can basically create your own SLMs, which is, that's great. Like I mentioned, so they've got built-in support these days for running SLMs. Google being Google, they automatically support their own Gemma models out of the box. So you can download the Gemma model, you can install the MediaPipe dependency, you can drag the Gemma model straight onto your Android device, put in the right path, run it, and it will just work, which is, quite cool. If you want to use other types, so things like 5.4 from Microsoft, or maybe, Llama, or any other kinds of model that you find on the internet, you need to do a few additional steps to be able to convert that into a format that MediaPipe is happy with. Fortunately, they help somewhat by providing scripts which you can run, which automatically does this. But if you've got like a really exotic model where they just don't know how this works, then you kind of need to go through a few steps as yourself to be able to do it. All of this is available on the MediaPipe developer site, which is really handy. But I would say it's kind of out of the comfort zone of mobile engineers, because you're starting to deal with Python, all sorts of like data sciencey kinds of stuff. But if you're brave enough to do it, I'd recommend it, because it is quite fun. At least I find it fun anyway. So once you've got your model installed on your app, on your Android device, it's time to talk to it. So the API that MediaPipe provides is actually quite simple. So from the top, you have something called a inference options builder. And this is just you trying to set up like the config for how you're going to communicate with your model. So the first thing is you actually need to tell your app where it lives, on your device. So this is just a file path. The next one is called maxTopK, and what that means is you're going to tell the model that you want it to consider the first X amount of thousand tokens, which are kind of like responses to something that you ask it. The thing you got to remember is like, because these models are kind of like, no one really knows how they're working, like they're kind of generating lots of different responses, and it's trying to allocate values to what it thinks is the most viable answer to the question that you ask. So you can configure this to try and make it work a bit more the way you expect. And one of the ways that you can do this is called maxTopK. There's another one, another value that you can set called temperature. And this is being able to say, right, I want you to give me the craziest, wildest answers that you can come with, or actually I want you to be quite safe and just give me answers that actually are factual or kind of make sense. So you can get quite creative here. So once you've set up your config, you pass it into the LLM inference, which gives you the interface that you'll be able to speak to the AI model to. And then you just call generate response and pass in a string. And that string will be your prompt. So that could be a question, it could be a command, it could be whatever you want. And then what will happen is the LLM will get the prompt, it will do its thing, it will eventually come up with an answer, and then you pass the result back, and then the result is for you to do whatever you want with. This snippet is very brief, and I'll give you some personal tips on things I found. So don't do what this is showing and just try and generate a response from the LLM, because first of all, it'll block the UI because it's running on the main thread. Second of all, you've got to remember that you're actually dealing with a file. So you're actually doing file operations. So you go and actually do something with this file, this file will give me an answer. So you actually need to treat it, as if you're doing an IO operation. So this is use dispatches to move onto the IO thread, use a suspending function, that sort of thing. So make sure you wrap any kind of generate response calls you make with in an IO thread, and that way you unblock the UI, and you're dedicating a coroutine to it as well. So once you've got your model all set up in your app, it's working great. At least you can tell it's working great. You can begin to provide additional information. And the way that you do that is using a very fancy term called Retrieval augmented generation. So what this basically means is, as part of you asking the model a question, you're also going to provide the model with a bunch of information that it can go and access, kind of like a library. Library full of books. You want to find some information about a certain topic, you take a book, read it. Now I know about it. You're kind of doing this for the models. So the reason you do this is if you want to have a model that is going to be able to have a very specific purpose or wants to have very specific knowledge, you need to give it that information. And once you do that, as well as having the power of what the model is already capable of and what it knows, it can also go away and read information from this this process and be able to take it into account for its own answers. This is how it looks very basically. I'm probably not going to do it justice because it's a very data sciencey kind of subject, but I'm going to have a crack at it. So first of all, you need to take chunks of text from a data source. So we could quite easily just have a text file, and that text file could contain paragraphs of text. And the chunking happens when you're putting the lines between the paragraphs. It doesn't have to be a paragraph, it could be a sentence, space, sentence, space, sentence, space. And that's your chunk data. You then go and use something called an embedder, which then takes those chunks of data and then it turns them into something that's called vectors, and then it stores them in a database. So if you've heard of things called vector databases, they're quite popular in AI and trying to match relationships, that kind of stuff. This is the kind of stuff that vector databases do. They essentially convert this chunked data into numeric representations, and those numbers are meant to represent relationships between those specific chunk data. So when you begin to ask the LLM, the SLM questions, it'll go away, it'll query the vector database. The vector database will take that query, it'll convert that query into numerical representations, and then it'll try and find the similarities between the chunk data that it's already holds and what's been asked. And then that will be used to try and pass the most relevant information to the language model, and then that language model will use it to give you an answer. I'm not sure I understand that, but yeah, quite tricky. Yeah, so like I say, SLMs can access those, well, once that data has been transferred in the vector database, they're called embeddings, and yeah, it provides the most relevant chunks for a response. I've tried to map this out in a diagram. I've also tried to apply some like Android architecture to it, so you can kind of see where these will fit into the layers. So starting at the top, you'll have your retrieval augmented generation pipeline. And because this is all dealing with databases, like files, you know, this is going to sit in your data layer of your app. So if you had, you could deal with this with a couple of different ways. You know, you could have, a scheduled job where you want to kind of pull in files and do this kind of stuff like every day. This pipeline, you can do it in lots of different ways. The example I've done here is, so starting from the bottom right, is I've got a prompt that I'll ask an SLM is, how many people regularly attend Mundroid in February? I've also got in my chunked file at the top left, my sentences that I want to convert. You can see like one of them is talking about February 2025, where 90 people turned up. That gets converted into the numerical representations for the vector database using an embedder. And then every time there's a prompt, this could be a use case coming from like the presentation layer, going into a domain layer. And then the SLM sits in the data layer because it's a file, remember, IO, the threads, that sort of stuff. The SLM will then go to the vector database, try and get something that's quite relevant. We're talking about February, so February might seem like something that's quite interesting to it, so it may take that as a response, and then the SLM will pass that response back to the caller, which could be the UI, it could be something else. You're not always guaranteed to get the answer that you'd expect because it's AI. When you hear things about hallucinations, or you've probably seen yourself where you're just getting answers where you just go, that's just wrong. So just bear that in mind. Like, this is how it should work in a perfect world, but as we all know, AI is not perfect. So yeah, I'm going to finish off on this last slide where I'm going to talk through some best practices. If you go away and try this for yourself, I think this will be really useful for you. So the first one is, first enough, whatever mobile phone device emulator that you're using, make sure it's got enough resources. So make sure it's got enough RAM allocated. I think these days, like 5 to 6 gig of RAM is plenty. Also, make sure when you're setting up the interface that you have the right configuration. One of the things that you can configure is whether it uses a CPU or a GPU as part of like the computation. Naturally, agents, LLMs are quite GPU heavy. So if you've got a phone that's quite recent, like Pixel phones in particular are quite good, Samsung recent phones, they can handle these models quite easily. I don't think we're quite there yet, where mid-level, mid-range phones, definitely low-range phones can run these models, which I think is a real shame. But I'm hoping as the years go by and obviously hardware gets cheaper, you'll be able to see more of these models filter down to like the mid-range phones. So that's a good one to keep in mind. The second one, treat the SLM as a data source. So remember, it's just a file. Okay, it's this AI that can give you all sorts of responses, but in terms of where it sits within our architecture as Android engineers, that needs to be in the data layer, that needs to be wrapped up in an IO thread. And when you're starting to feed and receive information, just treat it as if you're reading the file off the phone. If you're using retrieval augmented generation, make sure the file isn't too big. The reason for this is, if you've already got an AI model on your phone, which could be half a gig, a couple of gig, and then you've got a lot of chunk data, you're going to have a huge app just for, it could be a small use case. So you need to take things into account to try and mitigate that. You could end up trying to download the chunk data from the network. That could be a possibility.
Japan, by Google.
They could try. I mean, they're not going to get very far with the marketing, but yeah, that's one of the options that you could do. And yeah, finally, working with SLMs is not an exact science. As we all know, of using AI models, they can give you the randomest answer. They can give you the plainest wrong answer. But when you're trying to use it for your own use cases, you've got the power to try and iterate on that, to try and smooth out the rough edges, the incorrect answers. It's an iterative process, just as software engineering is. So enjoy the ride, experiment with it, and yeah, see what you come up with. Here are some links that I recommend that you will go away and look at if you want to go home and try these things for yourself. The Microsoft Azure SLM website is really interesting. They give a really balanced view of this field. You've also got the MediaPipe inference guide. These are Google developer pages. The AI Edge RAG guide, that's another Google developer page. The Google Developers Community Discord. So there's a lot of buzz in there from AI researchers trying to use everything from huge AIs like Gemini to the smaller ones like Gemma. Yeah, there's a really vibrant community there that I'd recommend if you want to get involved. And last but not least, this is my personal GitHub repo where I've been using this kind of technology just for my own hobby. I'm actually using Gemma free to create a game of Simon Says. So you kind of get a text kind of input where you can kind of speak with the AI. It acts as Simon, so it tells you to do push-ups, sing your favorite song, that sort of thing. This is it's a really fun project to try and get involved into this area. So if you're looking for something as inspiration, there's something there for you. I'll also share this presentation as well online, so if you want to get those links, you'll be able to get them as well. And that's everything from me for tonight, so thank you for listening. If you want to learn more about AI models running on mobile, I've got a blog post about it on my website. I also message on various social platforms these days. There's too many to mention, but that's my usual handle. But yeah, thank you for your time, and I hope you enjoyed the presentation.